Students, today we will discuss one important topic from electrochemistry, that is types of conductors. I am Dr. S.R. Pujari, Associate Professor, Department of Chemistry, DBF Dayanand College of Arts and Science, Solapur. Student friends, electrochemistry is a very important branch of science, and particularly it is a branch of physical chemistry. It mainly deals with the study of chemical changes produced by the passage of electric current, that is electrolysis. The examples of this process is the production of hydrogen, oxygen, chlorine in the form of gaseous state, NaOH, extraction of metals, electroplating. All these are the examples of the process where we are using chemical changes by we are getting chemical changes by applying the electric current. And second is the reverse of that, that is the production of electric current as a result of chemical changes. The examples of these changes are voltaic cells, Daniell cells, accumulators, dry cells, etc. In these batteries, what we are doing, we are producing electricity by the use of chemical changes. Now, first we will see the conductors and insulators. Whatever the substances we are seeing around us, they are classified in major three types. Some substances are conductors, some substances are insulators, while some of they are in between these conductors and insulators that we call as semiconductors. So conductors, these are the substances which conduct electric current. So the substance which allows electric current to pass through it is called a conductor. The examples of conductors are all metals, are good conductors of electricity. Graphite, a non-metal, but it is a very good conductor of electricity. Electrolytes such as molten salts or fused salts, aqueous solutions of acids, bases and salts are the examples of conductors. Another class is insulators. So insulator are the substances which does not conduct electric current, or a substance which does not allow the passage of electric current through it. Such substances are classified as insulators or non-conductors. The examples of these insulators are all non-metals are insulators, glass, mica, sugar, etc. The molecular type solids, they are non-conductors of electricity. Now the topic of our today's discussion is types of conductors. There are two types of conductors, electronic conductors and electrolytic conductors. On the basis of their mechanism of conduction, we are classifying these conductors in two types. Now, electronic conductors, these are usually metals, hence they are also called as metallic conductors. So electronic conductors, they are also defined as metallic conductors. Why the name metallic conductor is given? Because mostly these conductors are metals. So we will discuss now electronic or metallic conductors. Solid metals consist of positively charged ions immersed in electrons. Take any solid metal as a conductor. So if you see the structure of any metal, what is how the structure it is, the positively charged ions, they are immersed in electrons. So electrons, they are mobile, they are free. So positive ions do not move while electrons are free to move. When a metal is placed in an electric circuit, when we apply electric current to that metal, what is happening? Electrons are moving from one end to the another end, and they carry negative charge, that is called as current. So this negative electric charge is carried out by the electrons, while the metal ions, they remains stationary. So here the most striking feature of this electronic conductor is that the metal remains as such intact. There is no any deterioration of the metal. but they are carrying electric current. So how it is happening? The electrons, they are added to one end of the wire and drained off from the other end. And thus metal conductors remains everywhere electrically neutral. So in case of metallic conductors, conduction takes place without producing a chemical change. And therefore, I told you that the electronic or metallic conductor remains as it is even after conduction. So here in this cartoon, I have shown the structure of a metal. So this is the structure of metal. The positively charged ions here, they are represented by these cations. So these cations are the positively charged metal ions, and these are the electrons. So these positively charged, whatever I am marking by red, these are the cations. They are stationary. They never move when we apply electric current to this metal. While these electrons, they are mobile. They are moving from negative to positive end, like this. This is called a hopping mechanism. So thus electron is added from one end and they are drained off to the another end, while my metal remains as such. So this is the mechanism of electronic or metallic conductors. Now we will move towards a second type of conductor, that is electrolytic conductor. In electrolytic conductors, there are particularly electrolytes, acids, bases, and salts, or even the salts in molten state or in fused state. All these are good conductors of electricity. Now in these electrolytes, the mechanism of conduction is totally different. The electrolytes in a fused state or in aqueous solution, they furnish positive and negatively ions. When I say electrolyte, they are dissociated in the form of positive and negatively charged ions. So there are no free electrons in an electrolyte, or even you can say existence of free electron cannot be there in an electrolytic solution. So whatever the ions, positively charged ions and negatively charged ions, they are free to move through the solution. So when we apply electric current or field to this electrolytic solution, these ions, cations and anions, they are moving towards their respective electrodes. The basic science we know regarding this is that cations always moves towards negatively charged ions, negatively charged electron, while anions moves towards positively charged electron. So the simultaneous movement of these ions constitutes the electrolytic current. So in case of electrolytic conductors, electricity flows by the migration of ions. And once when I say migration, these ions gets discharged at their respective electrodes. And therefore, in such type of conductors, the transport of matter is happening. So here, if you see this in this cartoon, in a beaker, I have dipped two electrodes. One is negatively charged, so this end is negative and this end is positive. So negatively charged electrode has plenty of electrons on its surface, while positively charged electrode is deficient of electrons. So if I say NaCl solution, the aqueous solution of NaCl is added here. So when I say NaCl, I know it is an ionic solid. So the solution contains Na plus and Cl minus along with H plus and OH prime from water. Although the concentration of H plus and OH minus is less, but they are present in the aqueous solution. So when I apply current, what happens is that the positively charged ions Na plus, they are moving towards negatively charged electron, while negatively charged ions like Cl minus, OH minus, they are moving towards positively charged electron. And Na plus takes electron from that cathode and it reduces on the surface of cathode as a sodium metal. While on the surface of anode, we get oxygen gas bubbles. Oxygen gas bubbles. So the main important point here is to say that in electrolytic conductor, transport of matter happens, unlike to that electronic or metallic conductors. So today we will stop here and we will discuss in our next video the further basic types of conductors. Thank you.